what would be the observation after first iteration?
We'll get the max element at last.
Yeah. So for remaining elements will be non-sorted, but
We'll
out
get
we'll
zero.
get the last element at I mean maximum element in the end of the array, right?
Yes.
So that means, can I say that my highest element of the array is sorted? Right?
Yes.
Before that, if you do, or if you do the sorting, or if you doesn't do the sorting, the last element position is not going to change. So here in this one, whenever I do the first iteration, this element will go into the last position. Whenever it is going to the last position, remaining elements may or may not be sorted, but the last element is sorted, correct? So that is what the bubble sort does. Each iteration, it will do the sorting from the end of the array. And we have written a code also, like we have written a code with a while loop, we have written a code with a for loop also, right? And now let's look at the time complexity of this program, and then we'll move on to some other interesting topic called two-way merging. So let us take this as a code. Now, time complexity is nothing but time taken by the program. We don't tell in terms of time, minutes or seconds, but we do the time to complexity in terms of big O notation that we have seen earlier, right? So in order to calculate the big O of notation, I need to look at each line of code, how many times it will execute. Now, can someone tell me how many times this line will execute?
One time.
Only once. Now, how many times this will execute?
Uh, Length plus one.
Yeah. So
Length.
here, because see, when I say execute, how
Mhm.
many times, when I say it can, whenever you execute a condition, it can be the condition can be false or the condition can be true. Both the times you are evaluating a condition, correct? It doesn't matter what is the output. See, in order to know that it's a false, in order to know that it's a true, you are executing that. So I'm asking how many times this is executing, but when how many times it will go inside, that's a different scenario. Because how many times it will go from line number 21 onwards, whenever this is true, then only it will go. But how many times this will be evaluated? So since you are, if for example, if my length of the array is 10, correct? In the last class we see, right? We saw, see 1 to 10 it will execute. So 10 less than 10, it will fail, but still it will execute. And including 0, it will be 11, correct? I hope you guys remember the logic, right? Or should I explain again that one?
Yes, fine. Remember the logic, yes.
Yeah. So 10 plus 1, total it will execute for 11 times. So what I'm doing is I'm assuming that array dot length is n, like int n equal to a dot length. Okay. So I mean, worst scenario you need to tell whenever you are calculating, you're not calculating. See, here time complexity, I'm not calculating time in terms of hours, correct? So worst scenario, best scenario will be there, right? Worst time, how many time loops will execute? See? This is n plus 1 times. Okay. So even if it is n times also, will there be any big difference? You tell me. For example, if I put minus 1, will there be any difference? It will execute for n times, correct? So what about this plus 1? These are constants. So whenever you calculate the final calculation, this constant will be taken off, correct? So that is not a big deal, like whether you can think it as a n or n plus 1, but technically speaking, it is a n plus 1. And this condition will execute. Line number 23 will execute how many times?
Uh, N times.
N times, correct? Because 0 to 10, so 0 less than 10, 0 less than 10, 1 less than 10, 2 less than 10, 3 less than 10, like 9 less than 10. So 0 to 9, it will be counting. And whenever 10 less than 10, the condition is fail. It will not come inside. Now, how many times this condition will execute? Now the question comes here. So this is a loop inside loop. Now, let us take when j equal to 0. How many times it will execute? So that means first outer loop you started and you are coming inside. And then how many times this will execute? I equal to 0. Can I say that n times?
N times.
Correct? Now again, similarly, j will become 1, correct? You agree with me?
Yes.
J equal to 1. How many times it will execute?
N minus one time.
Again, n times only, right? Because you are starting with 0. J equal to 1. Again, it will execute 0 to A dot length or n minus 1, whatever it like. As I mentioned, the constant is, I mean, you don't need to worry about the constant. So can I say the worst scenario, it will execute for n times?
Yes.
So like, for example, if my j is 10, so when j value is 1, it has executed for 10 times, correct? J equal to 1, 10 times. So I'm telling that my length of the array is 10. So that means, let us take simple one. Length of the array is 4. Okay, length of the array is 4. So 0 less than 4, it will execute. J equal to 2, it will execute, correct? J equal to 2, n times, that means 10 times. J equal to 3, again 10 times, correct? Now, whenever j is 4, what will happen? 4 less than 4, the condition is true or false? 4 less than 4, the condition is false, correct? So it will not come. So now you tell me, guys, how many times this inner for loop is executed? Total 10, 10, 10, 10. That means 40 times. 40 times, can I write it as 4 multiplied by n, correct? What is this 4? J value, correct? Because your j value is 4, array dot length, I have taken it as a j, I mean, a dot length is 4. So can I take this array dot length as a 4, correct? So that means this inner for loop will execute for n into n plus n times, correct? You agree with me?
Yes.
Does
Often.
everyone understand? How did we arrive at array this one n dot n multiplied by n? Okay, I take that silence you understood. And if you look at these conditions also will execute n into n times, correct? Because this condition is inside the loop only. Now this is some conditional based. Whenever this value is bigger, it will execute. Worst scenario may be n, or you can ignore this for time being, because it can be n into n plus 1 or n into n minus 1 or something, correct? But this also and all this. So now if you look at the overall, the first condition will execute for 1. Second while loop will execute for n plus 1. Now internal loop will execute for 23 line number will execute for n times. This, sorry, n into, again, outside I equal to 0, n into n, correct? N square. Let's write here. Now this inner for loop will execute for n square times. Now this condition will execute for, again, n square times. And this will execute for end bracket is n times. So I'm forgetting all of this. And this will execute for 1. Line number 40 at the end, correct? After the loop is completed, after the logic is completed. Now, if I sum all of this, 1 plus 1, 2 plus n plus n square, n square, n square, 3n square. So this is the equation that you got. Now, for example, if let us take if n value is this much, 1 lakh, n value is 1 lakh. So compared to 1, so what if I put this n value here, 3 into 1 lakh square, what will happen, guys? Plus 3 into 1 lakh plus 2. So compared to this 1 lakh square, this value is very small, correct? And this is a constant. You can get rid of this constant. How you are getting this constant? Because how many number of lines or how many number of initialization systed out that you write, you get one only for one. So you can get rid of this constant. Now when I compare n square with n square is a bigger value, and I can ignore n. For example, if I consider the n value as 1 lakh, 1 lakh square will give you how many zeros? 1 followed by, and again 5 zeros, correct? 1 lakh square. So compared to this value will be small. So I'm ignoring this one. So what is left out? 3n square is left out. Now 3, how did I get 3? Because see here, this is 1 line, 2 lines, 3 lines. If I have some more lines, I'll get some more. So I can take off this one. So what is the time complexity? of bubble sort, big O of n square. This is worst case. That means whatever you give the code, the code will execute. See, even if I give the sorted array or unsorted array, it will execute for big O of n square. What is n here? Array length. For example, if my array length is 6, then 6 square. That means the code will execute worst time 36 times. Correct? So this is a worst case complexity for bubble sort. Now we can, I mean, if the array, as I mentioned, if the array is a sorted array is given, so you don't need to do. So we have to improvise that. I will tell you that little later. But this is how we can calculate the time complexity of a bubble sort. Any questions?
Sir, that big O, what is mean by that big O?
So have you joined the previous classes, or
Uh,
is this the first one?
I joined previous, but I joined at lately.
Okay. So time complexity, see, whenever you are representing the time complexity will be is nothing but a time taken by the program.
Mm.
So if I run this program in my machine, I will get maybe 10 milliseconds. Now,
Yeah.
if you run the same program again, can someone guarantee that it will take 10 milliseconds or it may be more or less?
Okay.
It may be more or less. We cannot guarantee, correct? Because
Mm.
it's a computer, it depends on your processor. Now, for example, my computer is having 8 GB RAM. Now, if I run this same program in a 32 GB RAM laptop, then it will take less time or more time?
Less time.
Less time. If I run it in a supercomputer,
Yeah, it will take.
negligible, correct?
Yeah.
It may, I mean, thousandth of millisecond also or nanosecond, it will complete, right? So that means the program execution time is dependent on your hardware system, right?
Yes.
So that means if I have to tell time complexity of a program in terms of minutes or hours, it's not right approach. That's
Oh,
why they have introduced a notation called big O. This is called as big O.
okay.
So now, how do you tell this big O? So this program will take 10 minutes or 20 minutes. That is not a right approach. So instead that we are telling in terms of n square, n, log n, 1, root n, or n log n. These are all the different time complexities. So
Okay.
we are denoting in terms of this. Now, whatever the program that we have written, what is the time complexity for this? Big O of n square. What you can understand here is what is n? Array length, correct?
Mm.
Given array length. For example, if I am giving six array length as 6, worst scenario, this how many loops will happen inside this program? 36 loops will happen. Worst case. I'm
Mm.
not telling every time. See, sometimes whatever the input that we have taken, after 4 iterations, it has sorted, correct?
Yeah.
So that means it did not go till 36. That means what the time complexity of big O of n square will tell you, worst case, it may go to 36. But the program can complete before that itself. So that is nothing. In order to represent that, we use big O.
Okay.
Okay. Hope you understand, right?
Yes.
Yeah. Others, any questions? Okay. If no, let's move. So there's space complexity, which I will explain tomorrow because you might get confused. So next topic that we are two-way merging. And what now? Another question I have told you guys. So what happens if the array is already given sorted order? So which also I will explain tomorrow. Like all the things I don't want to explain in single day. Let's move on to I would like to introduce you guys to one new topic. So two-way merging. Or let me give you the problem statement. So I have an array like 4, 6, 9, 10. This is first array, and second array is this one. These are two sorted arrays are given. Two sorted arrays are given. Write a program to merge these two sorted arrays. Okay. Write a program to merge the two sorted arrays. Now, what will be your answer? Anyone? You can guess it. You don't need to be right. You can unmute yourself and speak, or you can put it in chat. Two arrays are given to you, and the question is asked you, write a program to merge these two sorted arrays. Am I audible, guys?
Yes, Karthik.
Yeah. Any guess, whatever the answer that comes in your brain?
It will merge two arrays.
So you simply say that this is A and this is B. So what you will do, you will create a C, which length is A dot length plus B dot length. Okay. And for I equal to 0, you copy all the elements to C to A. And for J equal to 0, and you copy all the elements from C to B. Now you got the C array, which has all elements of A and B. And then on top of this, you can apply bubble sort. Whatever you know, correct? As of now, you know bubble sort, you can apply, correct?
Yes.
So does everyone think that this is one of the solution? Or do you guys feel there is some other better solution?
No, we thought initially this like this only.
Yeah. So maybe this is a solution that everyone thinks, correct? Anyone who is going for an interview can answer this, correct? Now, in this one, what is happening? What is the problem in this approach is, so here, first, what you are doing, you are copying this array. That means this is a simple loop, I equal to 0, I less than A dot length, correct? So the time complexity for this big O of A dot length, whatever it is, big O of N, let us take. A array length is N, okay? Can I say that for copying, you will take the big O of N time complexity? That means simple for loop, agree?
Yes.
So for copying the C to B, again big O of M, let us take this B array size is M, okay? Because these two are different array length, correct? So big O of N plus big O of M. Now for bubble sort, how much you take? See, your C array size is Z, which is M plus N, correct? Now bubble sort, my time complexity will be big O of Z square, correct? Because Z is my length, right? So overall you're getting this N, M, the biggest one is big O of Z square, correct? Now I can reduce this. Instead of doing this N square, if I tell you the solution with N only, or if I tell you the solution with the Z complexities only, or if I tell you the solution with M plus N complexity, then is M plus N is lesser than Z square?
Yes.
Yes, correct. Let's see that. Now here you observe this, the arrays are sorted, guys. That is a key point here. Is it sorted? Elements are sorted. This solution will work for if the elements are sorted only. Now what you can do, the way you can do is 4, 6, 9, 10. Correct? Let's write 4, 6, 9, 10. Now 1, 3, 5, 11, 15. 1, 3, 5, 11, 15. So what is the output they are expecting? Output also should be sorted. You merge these two arrays and output should be in such a way that output should be sorted array, correct? Now, instead of this is one approach that we discussed that everyone answers, but another approach would be two-way merging. What is a two-way merging is, see, you compare, now what is the intention? These are sorted arrays only, correct? Sorted arrays means low to high, correct? Each array will contain low to high, I mean ascending order, like smallest number to biggest number. Now, if I compare these two numbers, let us take, I am comparing 4 and 1. So which is smaller? 4 and 1, which is smaller?
1.
1. So can I move it 1 to a resultant array? Correct? Directly?
Yeah.
Next I will go, whichever I moved, I will go down. Correct? I will go to the next element. Now 4 and, because these are sorted, that is the reason, correct? Now 4 and 1 I compared, 1 I moved. Now next 4 and 3 I will compare. Which is smaller?
3.
I will move, correct? Whichever is smaller, you need to move because your output also should be ascending order, correct? Now next move. Now 4 and 5, which is smaller?
4.
4. So you move 4. Now whichever you move, you go to the next element because you need to compare, correct? Now next element means 6. 6 and 5, which is smaller?
5.
5. So you move 5, correct? You go down. Now 6 and 11, which is smaller?
6.
6. Now next, go down. 9 and 11, which is smaller?
9.
9. You move 9. Now go down. 10 and 11, which is smaller? 10.
10.
Now, if you move down, do you have any elements in the array?
No.
Now then what I need to do? For these two elements, do you have anything to compare in the array?
No.
No. And these elements, what is the input prerequisite? Arrays are sorted. Can I copy directly this 11 and 15? Whichever is left out, correct?
Yes.
Yeah, in this scenario, A array, B array is left out. In some other scenario, A array elements can be left out, correct? Now, if you look at my array, is it sorted?
Yes.
So now, did I write any 2 for loops in order to do this combination? What I will do maximum? I mean, will write the code also, but this is a merging algorithm. This algorithm is called as two-way merging. Two-way merging. Okay. In the interview, they might ask you, this is a simple one. They may ask you, they'll give you 3 arrays. So now similarly, I have given you the example of 2 arrays. Now, can they ask you for 3 arrays? They can, correct? Now, how do you do now? My resultant array should be sorted array. How do you do? Similarly, you compare these 3, correct?
First.
Whichever is smaller, you move, correct? 0. Now go down. Now you compare these 3, correct? 5, 1, 8, which is smaller?
1.
1. Now next, go down. Now next, 5, 2, 8, which is smaller? 2. Now come down. 5, 3, 10, which is smaller? 3. Next, come down. 5, 4, 11, which is smaller? 4. Done. This array is completed. Now what is left out? 5 and 11, correct? 5. Next, 6 and 11, 6, 9 and 11, 9, 12 and 11, 11 and 12, correct? Am I able to get it?
Yes.
Now, what is the problem in this? So, see, if it is a 2 numbers, how do you compare each 2 numbers? You write if A of I is less than B of I, correct? Whichever, if this condition is true, which element is smaller, guys? If this condition is true, which element is smaller?
A of I.
A of I. So, what you are doing? C of I equal to A of I, correct?
Yes.
Okay. Now, if it is fail, if the condition is false, then C of I equal to which element? If the condition is false, what does it mean? B of I is smaller, correct? So I should move B of I, correct?
Yes.
Right. Now this is a only two-way merging. How many elements you are merging? 2 elements only. But in 3-way, if I have to perform this 3-way, then how do I do? How many conditions I should write? First, I will check if A of I is less than B of I, correct? If this condition is true, then which is smaller?
A of I.
Or B of I is a bigger one. If the condition is true, A of I is smaller. Now, this can be smaller than this one, correct? Let's take in this example. Now, let us take, I have written a condition like this. A of I is greater than B of I, 5 greater than 1. Is it true? Yes. Now, after that, shall I directly go or should I look for third element? I have to look for third element, correct? Now, inside this, I need to write one more condition. B of I is greater than C of I or B of I is less than C of I, correct? So that like that, should I do nested conditions or not?
Right.
So I have to write loop for if block inside a if block inside a if block, correct? All the combinations I need to write. Is it little tedious or you might miss something?
Yes, possible.
Correct? That is possible. So now, now what I can do? So this is called now, since you are merging 3 arrays, this concept is called as 3-way merging. This concept is called as 3-way merging. You can do. It is not possible. I'm not saying that it is not possible to do. You still, because the if block will execute only for one time. and the length of the array only, correct? Still you can do. But the thing is, you might miss something. Instead of 3, if I have 10 arrays, you tell me, writing the 10 arrays conditions, is it easy or difficult?
Difficult. Nested.
Difficult, right? So now what, since see this, I mean 10 arrays, if you're merging, it is called as 10-way merging. If you are merging n arrays, it is called as n-way merging. That is a concept name. Okay. Now, how can I simplify this? Now I have A and B and C, correct? Now first, now I know two-way merging. Can I apply two-way merging in A and B? Right? 5, 5, 1. So the array will be 1, 2, 3, 4, 5, 6, 9, 2. Well, 5, 6, 9, 12, correct? Now I got the result. A and B, if I merge it, I will get a array called X, and the size is A dot length plus B dot length. Now on top of this, can I merge C? Correct? So A and B, I got some, let us take that array is X. Now on top of X and C, I will compare, I will get the final merged resultant array, correct? So that means even if you have 10 arrays like A, B, C, D, E, F. Now what you can do, if someone is asking you to merge all of this, what you can do, merge A and B, you get 1, C and D, G, H. Now can you merge these two? Now after that, this is your final merge, correct? That means, am I making a typical here? No, I have written two-way merging one code, correct? Now that code, I will pass different arrays, correct? That's it. You agree with me?
Yes.
So instead of doing n-way merge, performing the two-way merge would be better. Now, why am I explaining this one? The merge sort works on the principle of two-way merging. Now, in order to perform a two-way merging, what is the prerequisite, guys? The input array should be in a sorted order. Just remember this statement. We'll use this statement, or we'll come back to this statement in the merge sort. So this is about two-way merging, how to write, what is the algorithm, how to write it. Any questions, or shall we get write the pseudocode and complete the coding? Okay, let's go into the coding then. Now, if I take these two, now what you guys doing? 4 and 1, correct? First, you are comparing 4 and 1. What is means 4? This is a array, this is a B array. Can I say A of 0, I'm comparing with B of 0?
True.
Correct? Yeah. If it is true, that's a different case. In this scenario, A of 0 is like 4, 4 less than 1. Is it true? Is it true? No. In this scenario, it is not true. So it will go into the else plot. In the else, what did I do? Whichever is smaller, I'm moving it to a C array. So that means before this, I'm creating a C array, correct? Int C array equal to new int of C array. The size is m plus n. Let us take that array. A size is m, B size is n. So C array size is m plus n, right? Now, C of 0 equal to B of 0. Agree? So now if I execute this code, 4 less than 1, which is true, which is false, it will go to the else part and C of 0. That means in the C array, 0th position, it has moved 1, correct?
Yes.
Now, what I should do? What am I doing after that? I'm going to the next element in the B array, correct? How do I go to next element in the array? See here, I have hard coded this. Now this logic I have to repeat for all the elements of the array, correct? In order to repeat it, should I use some loop, or should I use this hard coded values? So I should use some loop, correct? Now while, so what am I doing? Till the last element of each element I'm comparing, correct? So the length of array is m, length of array is n. So I'm taking I equal to 0, j equal to 0, and k equal to 0. I is for a, I less than m, and j less than n. Till I less than m, j less than n. So let us take I value. What is I value? 0. What is the j value? 0. So A of J, so A of I less than B of J. That is nothing but A of 0 is less than B of 0. That is 4 less than 1. Is it true? No. Then I have to move this B of 0 to 0th position. So K I have initialized to 0. So let's put K and J. Now, once you do it, so that means 1 is moved to the resultant array. After that, what element you are comparing? 4 and 3, correct? How do you go to 3? In which index 3 is present? First index of B. So that is, can I do J plus plus? So that you will go to the next array, next index, correct? You guys agree with me?
Yes.
Now, after that, now next, you compare 4 and 3. 3 will go into which index? First index, not the 0th. So I should do, after assigning, I should do K plus plus also, correct? If I don't do, what is the value of initialized K value? 0. Previous value will be overridden, right?
Right.
Correct. Now next, 4 and now the loop will execute, correct? What is the value of I? It's 0. 0 less than, what is the size? 1, 2, 3, 4. 0 less than 4, it is true. And J is after adding J plus plus, because J will become 1. 1 less than 1, 2, 3, 4, 5. 1 less than 5. The condition is true. It will come. What is the value of I? A of 0 and B of 1, correct? Because J value is 1. Now, what it is comparing? 4 less than 3. Is it true? No. It will go again. So C of K equal to B of J. That means C of 1 equal to B of 1. So 3 is moved, correct? And then J plus plus. J will become 2 and K will become 2. Now I is still 0. J is 2. Now that means, now what you are comparing? 4 and 5, correct? Now 4 less than 5. Is it true? Yes, the condition is true. Now it will go into the if block. In the if block, whichever is smaller, I should move. If the condition is true, which is smaller? C of K equal to A of I. That means the 4 is moved. Now after that, I plus plus and K plus plus. See, since I'm moving I need to increment I, correct? So I'm going now. Now next I value is 1. It is no longer 0. 1 less than 4, true. Now 5 and 6. 6 less than 5. Is it true? No. So see, 5 is moved and J will increment to 3. K will increment to, already K has become 3 here. Now K has become 4 here, correct? You're following me?
Yes.
Now I is 1, J is 3. Now 3 less than 5, 1 less than 4, true. So 0, 1, 2, 3. Now what is the 1? 6 and 11. 6 less than 11, yes. So 6 will be moved, correct? And I value will become 2 and K value will become 5. It's because it here 4 already there. So 4 plus plus 5. Now next, I value has become 2. 9 and 11, correct? Which is smaller? 9. So 9 will be moved. No, I value will be incremented because it's a first array. And K value will become 6. Now next 10 and 11. 10 is smaller, correct? 10 will be moved. And the I value will become 4. And K value will become 7. Now if you look at, whenever the I value is 4, what is the initial I value is 4? What is the length? 1, 2, 3, 4. 4 less than 4. Is it true?
Yes. Sorry, false.
It is false. That means, whenever this condition is false, what does it mean?
We need to stop the execution.
So yeah, that is correct. But when the condition will be wrong, I mean, if the while loop is not satisfying, functionally, what is the meaning? You started with I equal to 0, j equal to 0, and one of the condition is failing. I less than m is failing and j less than n is failing. That means, can I say either, see, until you have the elements in both A and B, then only you can compare. If the condition is failed, what does it mean? Either you have to you have reached the first array end or second array end, correct?
Correct.
So either, I mean, I repeat my word, either you have reached the end of the first array or you have reached the end of the second array, whichever the condition, because it's an AND. So that means I have, in this scenario, I have reached end of the first array, correct? Done. Now still, that means I have copied till 10 only, correct? What is left over?
11, 15.
11, 15. So 11, 15 are from which array?
B array.
B array. Do you have anything to compare in the A array?
No.
So what you need to do? You just copy. What is the J value? J value is 3, correct? See, 0, 1, 2, 0, 1, 2, you copied the elements, correct? Only 3 and 4 is left out. So how do I do? So since whenever this loop is completed, can I simply write while j less than n, c of k equal to b of j, j plus plus, k plus plus. So then what this loop will do? It will copy the rest over elements to the c of k, which is 11 and 15, correct?
Yes.
This is one scenario. For example, in some other example, there are some more elements here. Let us take that 20, 21, 22, 23 are there in this. Then in this example, what you have? A array size is more than B, correct? So that means I am writing two loops while I less than M, C of K equal to A of I plus plus, K plus plus. Now, you guys tell me. So when I have three while, see, this is first one, this is a second one, this is a third one. Now, at any point of time, how many loops will execute? Let's look at in this scenario first. I have looked at in this scenario. What is the I value already? 4, correct? Now, J value 3. So this loop is broken. Now you're coming here, 3 less than 5. Yes, it will execute. That means it is copying third element and fourth element to the resultant array. Done. Now this, if you look at this loop, even though you have written, will it execute? 4 less than 4. Will it execute? No. That means though technically speaking, 3 loops are present, at any point of time, how many will execute? Only 2 will execute, because now you don't. Why did I write these 3? The below 2. These 2 loops are used to copy the leftover elements from the A array or B array. In some example, A array will have the elements. In some example, B array will have the elements. So these two arrays have written to copy the leftover elements to the resultant array, correct?
True.
Yeah.
But
So, yeah, go ahead.
but sometimes it may be A and B are equal.
Even though A and B are equal, so
Uh,
let us take that, say 4, 6, 9, 10, 1, 3, 5, 11. Let us take 15 is not there. So whenever you compare 9 and 10, 11, 9 you will move. 10 and 11 you will compare. 10 you will move. But 11 is still left out, correct?
yes.
So that means even though arrays are equal or bigger, you need to hold the whenever this condition is broken. What does it mean, guys?
Right.
When I less than M and J less than N, correct? When this condition is broken, any one element will be left out, correct? That you need to copy the resultant array. So we are using this loop, correct? Hope you understand that.
Yes.
Yeah. So now let's see what is the time complexity. See, the reason we came for this solution to look at the time complexity, right? Because earlier one, if it is a normal way of clubbing A and B to C array and then performing bubble sort on C array will give big O of n square, right? Now let's see here. So how many times, worst scenario, this while loop will execute? Either m times or n, whichever is smaller, correct? Because see here, I less than m, j less than n. Let us take m is 10 and n is 15. This loop will execute for maximum 10 times, correct? Because whenever 10 less than 10, it will fail. Like, so I can say that m or n or m plus n. Let us take something, okay, m plus n. Now this loop will execute for m times only. This loop will execute for n times only. So overall, it will execute for big O of m plus n or less than that only. So will it be better than n square?
Yes.
Yeah. So n square is nothing but, for example, n is 10, the n square will give you 100. If m is, in this example, m is 4 plus, this is 5. 4 plus 5, which is nothing but 9, which is far better than the previous solution. Now, why are we learning this one? So in the merge sort will work on the principle of two-way merging, so which I will start explaining in the tomorrow class. But now this is a two-way merging. So now, as I mentioned, so this is one of the hacker rank question, guys. Not hacker rank, like lead code. It doesn't matter what website you are using. Okay. Now, if you look at here, I'll share this one. You can write the code in this and try. If not, I will be explaining tomorrow. Okay. So now here, if you look at here, what is the first array is containing? There is a little change in the program, but don't worry about that. For time being, what you can do is, if you assume that your nums1 array is 1, 2, 3, it is a, forget about these zeros. They are asking, see here, what am I doing? I'm creating a, in this one, what is the C array? C array, new array I'm creating. So here they don't want to create a new array. Instead, they want to put the data in the old array only. That is the reason. Okay, we'll do that later. Now, see here, nums1, 1, 2, 3 is the elements. Nums2, 2, 5, 6. If I merge it, what would be the output? 1, 2, 3, 6. Correct? 2 is duplicated. Even though it is duplicated, what you can do? You can ignore it. Correct? Here, what our program is doing, even if it is duplicated, it is moving. But if you don't want, what I need to do? You can ignore whenever the element is equal. See here, what is the condition I have written? A of I is less than B of J. So if it is A of I equal to B of I, then what you can do, once you move, later you can ignore it, correct? We can do that later, not a problem. So here, see, it looks similar to the same two-way merging, but little bit of change. See, no one will ask you to write a program for two-way merging or three-way merging. They might give you the question like this and they'll ask you. So this we can provide, I just have written, look at here, whatever the code we have written, nums1 like while block, I and I greater than equal to 0. This is a little bit different solution, but this has worked. You can see it is accepted and all the test cases are passed. So which I will explain. Don't worry, in the tomorrow class, I will explain this program. But I just wanted to tell you that we started looking at two-way merging. Now, why did we look at two-way merging? So let's go to the merge sort. In the merge sort, again, the same array will be given, correct? Okay, these array is given. Okay, let's take one more element. Okay, now the property is to sort this array, but using merge sort. Now, as I mentioned, how does the merge sort will work? Merge sort will work on the principle of two-way merging, correct? What is the prerequisite for two-way merging, guys? What is the principle for two-way merging? Just now I have explained. What do you need the prerequisite?
Two arrays which are in a sorted order.
Two sorted arrays is needed, correct?
Yes.
Now, here, this is a given array. Is it sorted?
No.
No. How many are present? Only one is present, correct?
Yes.
So in order to make it, so now, in order to get the two sorted arrays, what we do is we follow the divide conquer algorithm in merge sort. Why do we follow the divide? Why do we need a divide conquer algorithm? Is the merge sort works on the principle of two-way merging. In order to perform two-way merging, you need two sorted arrays. So you are breaking the current array into a two sorted arrays. Like see, this is a 0th index, this is a last index 0, 0, 1, 2, 3, 4, 5. So what you do? 0 plus 5 by 2, you're breaking 5 by 2, which is nothing but 2. 2.5 something, but you take the 2. So that means, see, 0 to 2 is one array and 3 to 5 is another array. Let's take. That means this, whenever I say breaking, it is only for representation purpose. In the program, we don't break actually. We work with the indexes. 0, 1, 2, 10, 3, 9. 8, 7, 4, 3, 4, 5. Now, did I break the one array to a two arrays?
Yes.
But are these two arrays sorted?
Still no.
But that means I cannot apply the two-way merging again. So you do that again. So you apply the divide conquer here, you apply the divide conquer here. So 0 plus 2 by 2, 3 plus 5 by 2. The lower index is 3. See, if it is a new array starts with 0th index. But I'm using 3 means, am I creating a separate array? No. For visualization purpose, I'm drawing. But in the program, it will not happen. So 0 plus 2 by 2, 2 by 2, 1. That means 0, 2 is one array. 10, 3, 9, 8 by 2, which is nothing but 4. 3 to 4 is one array, 8, 7, 3, 4, 2, and this is separate array. Now you guys tell me, still, do I have the sorted arrays? No. You do the further revision. So this is individual element. You tell me, is this sorted?
Yes.
Now, how can you tell that it is sorted?
We don't have any comparison like
Yes. So that means, what is the best way to make blindly tell that my array is sorted?
it's if it's only one element.
Yeah. So that means, now if I break this down into 0 plus 1 by 2, 1 by 2, 1. So now this will become 10, this will become 3, this will become 9, this will become 8, this will become 7, this will become 4, correct? Now, what is the given array? This one. Now, my principle is to apply the two-way merging. For that, I need two sorted arrays. What am I doing? I am breaking the arrays. Whenever you break the arrays, immediately you get a question, sir, how long I have to break? When should I stop it? Now, you tell me, when should I stop it? Whenever I get the individual arrays, can I say that my arrays are sorted now? Because individual array, what does it mean? An individual array is something in which you have only one element. When you have only one element, can I say that it is sorted?
Yes.
Correct. So that means what? So using why are we using the divide conquer algorithm? So because the merge sort works on the principle of two-way merging, in order to apply the two-way merging, you need two sorted arrays minimum. So in order to get the sorted arrays, I am applying the divide conquer. See, this dividing, whatever the division you are doing, right? So this is one division, correct? This to this one division, this to this another division, this to this another division. So this division is nothing but a divide conquer algorithm. You are applying the divide conquer algorithm until you get a individual element arrays. Once you get the individual element arrays, what you can do? Can I apply the two-way merging?
Yes. Also.
Different ways I can apply. See, this is one way. Or what I can do, first 1093, next 1099, next 998, next this one, correct? See, these two I will result on top of this result, I will apply here like this or this one. Anyway, I can do the two-way merging. Now the resultant would be sorted array. Now if you look at if I apply the two-way merging here, let's see. 1093, which is smaller? The resultant array is 1 and 1. Resultant array will be 2, right? So 1093, which is smaller? 3. And 10 will come. So this is done. Now if I apply 8, 9. Now if I apply 4, 7. Now can I apply on top of these two now? So what is the resultant array? 2 plus 2, 4 elements, correct? 3 and 8, which is smaller? 3. Next, 10 and 8, which is smaller? 8. 10 and 9, 9, 10. And 4, 7. This is as it is. Now if I apply on top of these two, 3 and 4, 3. 8 and 4, 4. 8 and 7, 7. Done. 8, 9, 10, as it is. Is it sorted? This is how the merge sort will work. Let me show you something quickly. See, I'm just taking the merge sort Wikipedia. I just typed in Google that merge sort Wikipedia. Just go here. Look at here. These are a bunch of numbers. See, they're applying two emerging, 4 each. Next 2 each. Next 1 each. That means now I have broken down the original array to a individual arrays, correct? Now after that, 2 emerging is applied. See, 5 is smaller, 6. Now 1 is smaller, and then 3 will come. 8 and 7. 7 is smaller. So now that means first level of 2 emerging is applied, correct? Next, on top of these two arrays, see, 5 and 1 will compare, 1 will come. Next, 5 and 3 will compare. Look at here, the red color. Now 5 and 6 will come. Now 7 and 2, 2 will come. 7 and 4, 4 will come. And 7, 8 will come as it is, correct? Now, these two arrays are there now. You apply the two emerging, 1 and 2, 1 will come. Now 3 and 2, 2 will come. Look at here, whichever you are comparing, that is becoming red color. Now 5 and 4, 4 will come. 5 and 7, 5 will come. Next 6 and 7. 6 will come and 7, 8 will come. Right? Hope you understand, guys, right? The divide conquer is happening and then two emerging is happening. So the reason I have explained two emerging is these are some separate question asked in the lead code, and this concept also works on the principle of merge sort. Any questions? Which we will see, like the divide conquer, how to do the divide conquer, how to do the merge sort, everything we'll see in the upcoming classes. Any questions, concerns? I just shared this program, lead code challenge in the chat. If you guys wanted to try once, before I teach, you can try. Anyways, I am going to explain the program, like why did we use initializations, everything. It is also a two emerging, but little bit modified version according to the conditions mentioned here. I did not go through this. I will go through. Okay.
Sir, hi sir, good morning.
Yeah.
This is Mahesh.
Yeah, Mahesh.
Sir, how many classes did you take from today onwards?
How long I am going to take, or how many have completed, you mean?
How many have completed, sir?
Okay, okay. So this is just started on Wednesday, 20.
Okay. Okay.
1, 2, 3 we completed.
How
And the
many
first
topics?
one is just course content.
Okay.
Actually speaking, only 2 classes we completed, 21 and 22.
Okay.
So in the 21 and 22, I started explaining what is time complexity definition, what is space complexity, and bubble sort.
Okay.
Yeah. And today's was the third class.
Okay, sir. Thank you.
Yeah. Did you get a chance to look at the previous one?
No. This is my first class.
Okay. So in the previous one, I just explained these are collections and data structures batch. We just completed the collections. In the collections, we discussed about all this, like internal implementation of array list, how to create custom collection, how to create linked list, why
Okay.
to override hash code equals, linked list, custom linked list, like adding, deleting, printing, stack, custom queue, trees. So these are complete collection concept. We just completed before 20. And from 20 onwards, we started with this data structures.
Okay.
And in this course, we see time complexity, space, all the sorting techniques, searching techniques, graph, dynamic programming, matrix, pattern printing, and these are the various questions, frequently asked questions we're going to solve in this hacker rank or lead code, wherever it is.
Okay.
Yeah. And the duration of these data structures is 2 months. And collections we just completed that we have taken 1 month. Total is 3 months. Total fee is 10,000. Only DSA 7,000. Morning 7 a.m. to 8 a.m.
Okay, sir.
If you are interested,
Yeah.
you will
Yeah.
get
Yeah.
an email from the Ashok IT.
Yeah. Okay.
And I hope you guys have received an email from Ashok IT, right?
Not yet, Karthik. So till tomorrow we have the demo session, right?
Correct.
Okay.
Yeah.
Yeah. So I'll try to reach out today.
Yeah.
Let's see. And before jumping on this lead code part, can we have a program for the
Yes,
merging
correct.
you
I do
showed,
explain.
right?
I will explain.
Yeah.
Yes. So
So
whatever the pseudocode I am writing, see, I don't want to explain all the things in the first class itself, because it might see today you understood something. If I
yeah,
explain all the things, like it might get overlap. So that's the reason. Maybe if you can see after completing the sorting techniques, we'll be little fast, because
yeah,
now you might not know all these concepts, right? So
correct.
it might take time. Okay. So
Yeah,
those, who wanted to get more details, so what you guys can do is, see, this is a website. Just go to Google, type ashokit.in. This is a website.
mhm,
You can call on this number,
yeah,
or you can ping in the WhatsApp, like messages. They'll get back to you.
sure.
Okay.
Oh,
So if
thank you.
no question, then that's all for today, guys.
Sir, do we get any notes?
Yes. Let me quickly show. So I have prepared a note, like whatever, apart from whatever I'm explaining on the one note. If you want, I can give you that also, like whatever I'm typing. I'm writing with a pen, right? So I
Hmm.
prefer writing, like since it is a virtual class, I cannot. I'm a person like who is a fan of writing. So if it is a regular class, we used to be writing on the blackboard or green board, right? But it's a virtual. So how can I do? So what I thought is I can do with this pen. It is comfortable for me. So this is one of the Java notes I have prepared, not Java. Okay, you in collections in DSA, right? So these are notes that I've prepared, guys. So which will be shared with you all. These for collections, I'm just showing you the sample. Likewise, I do have for DSA for whatever I teach. Like it's
Okay.
like question and answer based, like what happens inside add method, or
Okay.
when what is the internal implementation of add method in array list. What,
So
yeah,
we will get
yes,
at the time
I'll
of
be sharing. Yeah,
completion.
once, yeah, not completion. Once the enrollments are completed, because demo classes, right? I do not know how many people
Okay.
are
Okay.
interested, etc. Right? So
Okay.
once you enroll for this course, you will be added to one WhatsApp group.
Hmm.
Already, all the enrolled people will be added to a WhatsApp group. So in that WhatsApp group, I will be sharing these notes or whatever the code I'm writing. I will also share that. And if you have any questions, you can post that question. For example, not only the question that I'm talking, you might see some question. Like, see, I explained bubble sort. You
Hmm.
got some question on over the practice something, correct? And you are not able to do it. So
Hmm.
you share that question, you ask me the question, I may be able to answer. Even if I'm not able to answer, I'll do it later.
Okay.
Maybe I see, I do need some time to, I'm also a human being. I cannot answer all the questions, right?
Hmm.
Yeah. So if I do not know the answer, I mean, I'll do my homework and then come back and I'll answer. Maybe it takes like 2 or 3 days or 1 week, but definitely I'll answer.
Okay.
Okay. So that's all for today, guys. Thank you all. Thanks for joining. Hope you learned something new. Bye.